Hi, good evening, everybody. I am Gopinath, Product Manager in Microsoft. I'm excited to be part of the build. Today, I will be talking about how you can achieve continuous delivery for your organization and automate all your deployments. I have Steve with me in the session. Please share if you have any questions with him during the session. We will get to them at the end of the presentation. Why continuous delivery or DevOps? Quality, speed, and efficiency are all tangible benefits of effectively implemented DevOps that lead to faster innovation and product differentiation. We have seen customers practicing continuous delivery and improving their efficiency significantly. Here are some of the benefits that they have seen. 22% improved quality of deployed applications. We have seen customers getting faster deployment cycle by 30 to 50x times. And we have seen customers practicing DevOps help them to take their code from commit to deployment 200 to 400 times. That's a significant. That helped them to increase the new software and services delivered to their customers. There are many ways of achieving continuous delivery for Azure. You can use Jenkins, you can use Azure pipelines, you can use GitHub Actions. In today's session, I will showcase how you can achieve continuous delivery using GitHub Actions. What are GitHub Actions? GitHub Actions are native to GitHub. You can get CI/CD built in right in GitHub. You can use to build, test, or deploy any application to any platform. You can automate any workflows, achieve end-to-end traceability. You can trigger workflows on any event and customize your workflows for your enterprise compliance requirements. GitHub Actions are community driven. There are more than 3,000 plus actions available and growing on a continuous basis to automate any workflow. There are many events that are available to help you achieve full-fledged software delivery cycle automation using GitHub Actions. Now, finally, GitHub Actions for Azure help you deploy to any resource in Azure with a simple and consistent experience. All right, let's get in action. I'll start off with a simple flow and then show few powerful GitHub features to achieve true enterprise continuous delivery. I will switch to my browser. What you see is a sample application. This is a Node.js sample application that I just forked from Azure samples. Now we will configure end-to-end CI/CD for this application using GitHub Actions. When I click on new workflow, GitHub Actions automatically suggest you few templates, and those include deploying to Azure or other clouds, or even they provide CI workflows and even your custom or enterprise specific workflows that are available. And it supports from any language and any framework. Let's pick ours and set it up for deploying to Azure Web App. As you can see, when I just selected the template, it automatically gave me the YAML code that is needed for configuring CI and CD end to end. So the first thing I want to do is, this is getting triggered on the event of release. I would like to change this event to be for every code commit. That's the first change I will do. Now, for the next set of actions, you can actually just see there is a rich marketplace that is available. As I was just talking about, every language, Go, Java, or there are many marketplace actions that are available. I'm just browsing to the GitHub Actions marketplace. You can see there are more than 3,700 actions that are available. You are free to use all of these actions, and the categories include from code review to deployment to monitoring to whatever custom requirements that are needed for automating your software delivery cycle workflow. Now let's switch back. Now for our purposes, if I just click on Azure, you can see all the Azure actions that show up here. There is Azure Web App, there is login, there is Kubernetes. You get many built-in Azure actions that are needed for you to target to Azure resources. Okay, now let's just get back to our demo. So we just configured the event now. The next step is, we have given instructions on how do you configure and then deploy this targeting a web app. So the first step is having a web app available and then create a web app publish profile as a secret. So I pre-created this web app. Now, if I actually navigate to this web app, you can just see that this is a standard one. So our first step is to get the publish profile and copy it as a secret inside the GitHub repo. I just got this. Let me just, go to the secrets and then configure it. The secrets are under the same repo settings. And here in secrets, I had already created the key, but let me just update it now. I am pasting the one that I just downloaded and update secret. So these secrets are stored in a secure, in an encrypted way. And, other than you, when you created it, it won't be, visible to anybody else. Now that our secret is created, the next step is updating the web app name version. So because our web app is already created, I'm just, copying the web app. Now that's it. For our purposes, we are done. Let me just walk you through what is there in this workflow. You can see, there are multiple jobs that you can define. And in this case, we actually have 3 jobs. The first job is, using the Node.js as the action for the specific version. Then it is doing a install, npm install, build and test. Afterwards, it is deploying to Azure Web App. Now for deploying to Azure Web App, all it needs is the web app name and actually the web app publish profile. And by default, it just uses the local directory for all the contents that get generated. That's it. Now my CI/CD configuration is set up. Now, if I actually just go to the actions, you will actually just see it getting triggered. And I can actually just see live updates built in, and we have agents that are available. Those agents will pick up and then run these jobs completely automatically. Everybody gets, free agents with a few minutes. While this execution is going on, let me just show you the various actions that are available. If you go to github.com/azure/actions, you will actually just see built-in GitHub actions available for you to target to Azure for continuous delivery. You can use Azure login and then execute CLIR PowerShell, or you can actually, configure ARM templates and get secrets from Key Vault so that you can actually follow the compliance requirements of storing all your secrets. And then we have support for web app, serverless, Kubernetes, all kinds of resources. Let me just see if this execution is complete. I think it is still going on. You can actually just see the live updates that are going on. One way I have shown you is how do we configure using the GitHub flow, but there are many ways that are available for you to achieve the CI/CD configuration. If we can go to Azure Actions Workflow Samples, we actually have built-in samples and built-in CI/CD flows that are pre-configured for you. I will just show you some examples. Like for every language, starting from .NET, Java, Node, Python, any of these languages, if I can just go navigate to the .NET sample, so there is a sample code built into here, and then there is a GitHub workflow that is available inside as well. So this is the ASP.NET workflow that is available, all pre-configured. You just need to change some of the parameters in the YAML workflow file, and you will get it. This just looks as simple as, the Node.js one that I have shown. How do you build, and then how do you deploy? And in the same sample, even in the README, we do provide the instructions, including resource creation too. So essentially, if you want to try out, all you just need to do is fork this repo, click on deploy to Azure, give all the template parameters that are needed, and configure secrets, and your CI/CD configuration is fully set up for you. Let's just go back and then see. So this run is completed. If I actually now click on, if I refresh this one, you should actually just see the repo that we had. Boom, there you go. So this is the code repo Node.js Express app that we had created. It is very easy for you to go from simple, using GitHub Actions, the end-to-end CI/CD configuration. What I will do next is, how do I just take this a simple workflow and then make it enterprise ready or achieve all the key shift left practices that are needed. So in the first workflow, you have actually just seen me having only single deployment. What I will do now is multiple deployments. If I go back to the GitHub workflow here, you can see there are 3 workflows that are configured. There is a pull request, there is a build, there is a deploy. So the first workflow had an end-to-end build, deploy configured. Now for enterprise requirements, we actually recommend customers to divide CI, CD, pull request separately. Let me just show you the pull request because this is a new one. Then I will just talk about build and YAML. So what we are doing in pull request is we are taking the power of GitHub Actions on every event, and we are trying to shift left so you can actually achieve the quality that you want or your enterprise requirements early in the life cycle. So on every pull request, this is a container-based web app. We are actually scanning the container image to see if there are any vulnerabilities that are included in this. And if there are any new vulnerabilities that are coming into this change, we will actually block the change for getting it merged into it. Let me show you this in action, and then I will walk you through all the other workflows. So typically, every developer, what they want to do is they just want to change their images based on the latest available images, or they want to use the latest packages that are available. They may not know if it is probably blessed by their enterprise or not. So in this particular case, I'm just picking up the node latest image, and now I will create a pull request for it using my own branch and updating the Docker file. That's fine. Now, once I submit my pull request, you will see that the new actions workflow will automatically get triggered. And once, there you go. So this workflow gets triggered. Now what this workflow is doing is, as part of your pull request, before it can get merged into it, it is trying to build the container image, and it will actually do a container scan. And if there are any vulnerabilities that are getting introduced because of the code change by the developer, this will be blocked from merging into master. While this execution is going on, let me just show you how exactly we have configured the next set of features that are needed for continuous delivery. I'm getting into, so build and deploy workflow. Deploy workflow looks as simple as the one that I have shown. Or, instead of having build and deploy in the same one, we just configured only the deploy into this. And it is same. We just take the resource group, web app name parameters, and the container registry where we want to deploy from. Now for the build action, if I actually just go to the build action, in addition to doing the build, there are 2 more jobs that we have added. You can see along with the build, we recommend running all the tests that are needed in the same workflow. And if that all the tests pass, you can actually configure even approvals too. And only after an external person comes and then following the 4i principle approves this, then the deployment job will be triggered. Otherwise, your workflow will get blocked right here. This is how you can actually achieve more shift left, more continuous delivery features as part of your workflow automation. Let's go back and then see if the pull request flow is complete. It is scanning now for vulnerabilities. While it is just scanning, I will show you one of the earlier pull requests that I have submitted. This is the one that I just submitted a few hours ago. You can see that the same, we have run the exact same checks. Everything was clean. If I just click a little bit more, so here is the container scan that it went through. There are no new vulnerabilities in this, but it just was giving me best practice violations. Now, if I'm just using the current one, we will actually know if there are vulnerabilities. There you go. The latest scan is complete. Now it automatically scanned, and then they said there are 4 new vulnerabilities that are getting introduced with this flow. This is how you can actually block as early as possible so you can achieve full-fledged continuous delivery for you. I'll just switch back to the PPT. What I have shown you is picked up a simple application, and I have taken this simple application from simple CI/CD end-to-end workflow into multiple shift left strategies, starting from pull request to taking it all the way to approvals, running tests, and making sure that every deployment that goes on here is secure and safe. The next one that I want to show, what we have seen is a single microservice that is getting deployed. What if I have multiple microservices in my application? Now let me just shift back to my demo. Here we have a rock, paper, scissors app available. Everyone knows about rock, paper, scissors. And let me show you the architecture of this. I'm just scrolling down. This is how the architecture of this application looks like. There are many microservices that are available, and each of these microservices is built in a different language. And this app is using Azure Functions for prediction, and it is using Cosmos DB, and it is using Web App Blazor, and all these microservices are actually getting deployed to Azure Kubernetes Service. Now, how do you automate this complex workflow using GitHub Actions? If I switch to my workflows, we have pre-configured the workflows. I'm now just going into the workflows. You can see there are multiple workflows that are defined. Our recommendation is for each microservice to create a separate actions workflow so that the team can independently operate, build, test, deploy each of that microservice in a separate workflow so that you have full independence, you have full control on how you want to configure and then deploy. We actually have even included provision resources. So the entire architecture that I have shown, which includes Kubernetes, Cosmos DB, all of these can be automatically provisioned using this too. I'm just showing you, and you can just see that we have an ARM directory that is available. This is where we are storing all our ARM templates. And anytime there is a change that is done to this specific workflow, it will actually provision or update the resource based on the change that was done. So this is what will give you infrastructure as code. You can store all of your infrastructure into the code and then use it to achieve the automation. Now let me pick up one of the microservice and then show you. I know I just picked up the .NET. Now, how does this look differently from the previous one? Like you can see that only the changes, if there is a change that is happening in this specific path, that is the .NET Player API, then only we are triggering this specific workflow. And obviously, if there is a change that was done in any of the Helm files, because this was a Kubernetes-based deployment, we are triggering this workflow. Now, if I see the workflow, it looks similar to the one that I had shown before, where we build the Docker images and we do a login, and then we set up Helm and then use the built-in Helm action that is available to actually deploy it. So using this, you can now end-to-end achieve full-fledged automation of your microservices independently with multiple microservices part of the big enterprise application. I will switch back to my presentation. That's deploying multiple microservices. So what are the various GitHub actions for Azure that are available? You can use GitHub actions for starting from a simple web app for container that I've shown, to functions, Kubernetes, Azure ML, or even databases of SQL, MySQL. And you can even use Key Vault as well in your workflow. Key Vault will help you to store all the secrets at one place and just to pull in the secrets that are needed for you to deploy the target resource. And we have support for every language: .NET, Java, JavaScript, Python, Go. You can just use the workflows to configure and then deploy any language as well. And today, I'm happy to announce that we have the workflow creation available at multiple entry points as well. In the demo, I have shown you how to create it from the GitHub portal, but you can actually create it from Azure portal as well using the deployment center. You can create it using an extension that we released to VS Code as well while editing the code. We even have a CLI extension that is available where you can actually configure end-to-end actions using this. All right, so that's the end of it. I recommend going to aka.ms.actions.cd. You will find all the samples, all the documentation that I just talked about or showcased in this demo. All the demos that I showcased are available in public GitHub repos. You can actually clone them. You can try it out.
Well, thank you very much, Gopinath. This is Steve, and I've been kind of sitting here watching along and really excited about some of the stuff you're showing. And we've got a couple of questions from our audience here about the stuff you're talking about. Now, you showed us microservices implementation. We have a question from Robert. They have a monorepo for all of their apps and services, and each one has its own life cycle and a number of shared libraries. Could you recommend a process using CI/CD with GitHub Actions to build and deploy a specific app only when that specific app or its dependencies change? And I think what you showed with that rock, paper, scissors, lizard, Spock demo, I think there's part of that pattern that would apply to this.
That's right. So I'll just switch back once so I can just showcase it. The recommendation that we have is there are many people, who are running into this where they are just trying to use the same, single monorepo for multiple microservices. The most important thing is if you have your directory structure that is configured appropriately, then you can actually use these microservices workflows to be triggered whenever there is a change that is happening. For example, this particular workflow will get triggered whenever there is a change in the .NET Player API, or the .NET Player CI/CD YAML itself gets changed, or the Helm files that are associated with it. So if we can just structure the same monorepo with all the code related to the microservice into the directory structure, now you can actually configure independent workflows.
Oh, very nice. All right, I think that helps a lot. We've got another question from Pritesh. Is there a way to set up environment variables and deploy into different target environments? For example, like a dev, a staging, and a production?
Yes. I think one way to achieve some of these is using the jobs. There are multiple jobs that are available. Each job is going to get executed separately. So you can actually create a job for your dev deployment. You can create a job for your production deployment and use the variables that I have actually just showcased. Like, I'm just switching again back to my demo to show some of the variables that were there in the first one. If I just go back to the first workflow that I configured, there are secrets, there are environment variables that are available. For example, these are all environment variables that are available. You can actually configure environment variables for each of the specific, either dev or test or production environment variables, and then configure them and use them appropriately in multiple jobs.
Okay.
Did that answer the question?
Yes, definitely. So you can create your own variables in the YAML. You can create your secrets in the settings in the repository, And then I believe there's also a bunch of like automatic variables, and there's probably documentation out on GitHub for that, right?
That's right.
Yeah.
That's right, Steve.
Wonderful. So we've got a few more questions, and we've got about 5 minutes left. So I saw, in your demos, you've got web apps, you've got Kubernetes functions, right? Are we restricted to those specific things, or are there other can we deploy out to other services, and are there limitations as to what type of Azure resources we could provision?
Good question, Steve. Today, you can actually deploy any complex application. For example, in the demo that I have shown you in the microservices one, we have shown you how do you, configure and deploy for functions, Cosmos DB as well. I'm just going to, this is the, my recommended, call to action too. If you go to github.com/azure/actions, you will actually just see a list of actions that are available, where there is a web app, serverless for functions, containers for Kubernetes available, and databases too. But the Azure Actions are helping in optimizing the deployment with the best practices with a simple and consistent way. Assume you're trying to deploy to Service Fabric. I'm just taking that as an example. If you want to deploy to Service Fabric, you can actually use the Azure PowerShell action that is built in and available to use the Azure PowerShell script to deploy to Service Fabric, or even for that matter, any other resource that is actually not listed here. I know customers who are actually just using some of these script-based, either CLI or PowerShell-based actions to configure and automate their deployments today for all of these specific resources, while we are building actions for every Azure resource that is available.
That's awesome. I love me some shell. So whether Azure CLI or Azure PowerShell, it's all good stuff. So we've got about 3 more minutes left, and I'd like to get at least one or two more questions. I think we can get a couple quick ones in here. Are there any languages or project types that are not supported?
Not that I know of. Given that GitHub is like OSS, and there are a lot of community actions that are available. If I just go back here, if I just click on continuous integration, I think you should just definitely find for every action type. I'm not aware of any specific one that is not being supported.
All right, great. And we've got a question that's come in from Barath. I apologize if I mispronounced the name. But can we use workflows in GitHub Actions to create labels, or can we use those actions to deploy based on a particular label? So, for example, we want to promote a particular build through environments. And would you have an example of that offhand, or at least point us in the right direction?
Yeah. So if you go to github.com/features/actions, you will actually find, like, here is where I'm just showing you the powerfulness comes from the GitHub's any event. You can see some of the events that I'm just showing on my screen. It can be on checker, on release, on repair, repository dispatch, on delete, or even changes done to the issue comment, labels. So every event that is there in GitHub can be used to automate your workflow and trigger it automatically. So the GitHub Actions is not just for achieving your continuous integration and continuous delivery workflow. You can actually use it pretty much to automate any software delivery cycle, right? It can be on issue creation, pull request, or release, or a change in the code, pretty much any event.
Yeah, that's actually what I think is one of the most powerful things about GitHub Actions is it can do CI/CD, and it can be good at that, but there's also all of these other areas of your workflow that it can tie into. So we've got 1 more minute, and personally, I would like to know, can I do concurrent builds? Because sometimes I have projects and I want to get a lot of jobs going all at once so that this build finishes fast.
That's right. You can actually create multiple jobs and then execute them in parallel based on the resources, based on the minutes that are available to you. I think we have 30 seconds to go.
Yes.
Thank you, Steve. Thank you all.
Thank you, Gopinath. We appreciate all the information you've given us.
Yes, I just recommend you to going to the Azure samples workflow and create, fork the repos and try out, GitHub Actions.